Hi everyone, welcome to Physics 380 Molecular and Cellular Biophysics. My name is Brenda and I'll be your instructor throughout this term. It's my second time teaching this course, and personally it was one of my favorite courses when I took this as an undergrad here. I did my PhD in biophysics under Professor Zoya Leonenko. You've probably taken or are taking Physics Bio 280 with her. So that's a good course as well. But Physics 380 is fairly different. Whereas in Physics 280, you were learning about how to look at biological things in a from a physics perspective. We're going to be looking at modeling for this course. So we're going to go down to the molecular and cellular level, and we're going to see why things take the shapes that they do and how they can interact with each other. So, for example, we're going to start off with protein folding. Why do proteins fold the way that they do, and how can we predict that behavior? Next, we're going to look at DNA. Why does DNA have that double helical structure, and how does the energetics work for DNA denaturization? Apart from that, we're going to end off with lipid membranes. So lipid membranes are my favorite because that's what I did my PhD in. I actually studied the interaction of drugs with lipid membranes. So there was a particular drug named daptomycin. It's an antimicrobial peptide that's really good against all gram-positive pathogens, specifically pneumococcus or for pneumonia. The only problem is that drug, when it goes inside your lungs, it stops working. It actually goes from essentially 100% efficiency to 0% efficiency. So my whole PhD was trying to figure out why daptomycin didn't work inside your lungs. And all of my studies were based on the interactions of daptomycin with different lipid membranes. So I had to model the bacterial membrane using a simplified set of lipids. I had to model lung surfactant inside your lungs using a simplified model as well. So everything I've done in my PhD was trying to make a simplified model so that I could perform studies on it. And hopefully throughout this course, you'll have the opportunity to explore something that you love as well. This is a third-year course, and I wanted to introduce something that would be beneficial to you in the future. Personally, as an undergrad student going into grad school, I never got the exposure to research that I would have liked. So in this course, I've introduced a research project. It's basically a literature review. All I want you to do is pick a topic that you really like that's related to biophysics, of course, preferably molecular and cellular biophysics. Look at that topic and do a literature review on it. That's probably the first step of any graduate student that goes into a program, and it's something that I would have benefited from if one of my courses had that. But it is a project that I want you to spend quite a bit of time on throughout the whole term. I'll be there to support you in terms of actually being able to perform a literature search. I'll teach you the ropes, or I'll show you the ropes on how to do it, how to leverage different research databases. I'll show you how to put things together, and of course there are different milestones throughout the term for you to check in with me to see how you're progressing. And each of those milestones will have grades assigned to them as well, just so that you can stay on track. Apart from this, the course itself really is fairly simple in terms of structure. Apart from the literature review project, there are weekly assignments. Apart from that, there is going to be a midterm, and there's going to be a final exam. So there's 4 different assessments worth marks. There's also a 5% bonus that I've introduced for this term. Because this course is based on modeling, what I'm going to do is create a bonus lecture series throughout the term. Probably going to release one every week or two, but I'll be presenting one model of a specific situation. You can choose to watch them if you have time. You don't have to if you don't want the bonus. But if you do watch the bonus lectures, you'll find that I'll be using a very simplified model to try and model something. And I would want to hear your opinion about how I can improve that model. So of course, I'm going to be presenting a really simple model. You're going to have to submit a written document or even a program or a presentation about how you would go about improving that model and actually try and apply that model to what I was trying to solve. If you want to tackle a new problem or create a new model for something else, you can definitely do that as well. Just get clarification from myself and confirmation that the topic is okay before you proceed. Throughout the course, there's going to be various resources that you can study from. I'm going to be preparing pre-recorded lectures every week, and I'll be offering one live session per week just to summarize those lectures and also to go through some practice problems. So those live lectures I'm going to offer twice a week. They're pretty much going to be identical because everyone's in different time zones now. So if I'm offering one at 9 a.m. per se, then there's going to be another one at 9 p.m. So I'll be setting that up with you at the beginning of the term just to get a good sense of your availabilities so that I can make the most out of your time as well. So apart from the pre-recorded and the live lectures, there are weekly assignments that you should stay on top of. They'll be due via CrowdMark, so definitely download Camp Scanner if you don't have it, or if you don't have a scanner at home, so that you can submit your assignments. And that's pretty much it for a weekly schedule. To help you out and to help you stay on track, what I've done is also created a checklist on Learn. So there's a resources tab. If you click on that, there's going to be a checklist module. So if you go to the checklist, I'll have a weekly checklist every single week so that you can check off on your progress and just make sure you're completing everything on time and staying on top of things. Just to end off, it's really unfortunate that I won't really be able to meet any of you in person. I've looked at the class list and I have met a few of you already, but for those of you who don't know me, I'm a very helpful person. If you ever need help or any support, contact me. I'm going to have regular office hours through Skype. I've also set up a Microsoft Teams group for the whole class so that we can all chat together on that platform. That means we can share files, we can work together as a group to solve different problems, we can help each other with literature reviews, and just to help foster a better community within our class. I hope this term goes well for all of you. Stay safe, and I look forward to meeting you when all of this is over.